Hello, this is my video for Project 1 in Mr. Osway's class. So I'm at the workshop and I'm going to just drag this over here, the fluid flow fluent. And here we're going to click on geometry. I opened up the properties menu with like a right click, went over here, and I just make it over here and I put it in 2D. Then I right click it again and I want to open Design Modeler. And once this opens, we can get to drawing out the shape of where everything's going to happen. Right here, XY plane, set to the Z, and then we can start our sketch. Now we want our sketch to be rectangle. Actually, before I do this, let me just change my units to millimeter and then draw the rectangle. That's good. To have a rectangle. That's much better. There we go. Boom. And then dimensions. We go make the vertical ones first. Right here. Make the horizontal one. Top bar here. And then we can give them actual dimensions right down here in the bottom left. Make the height 1 millimeter. And the top will be 150 millimeters. It'll be kind of a long tube, just like this. Now we can go to concept, surfaces from sketches, click on our surface, apply it, and then generate that, and then just kind of shades it in. That's the surface that it's applying to it, just from the sketch. That's all we needed to do here. We can now leave and go to the mesh. I want to update this first though. Make sure it did it right. Now we can go open up this. This one sometimes can take a minute. The one that really takes a while is the setup for the second case. That one always takes a while, but we'll get it done. I don't know why it always opens this one first. Anyways, mesh. We can go and insert our first mesh, the method, and just click on the shape, apply it, and we can just generate it. We don't need to change any settings here, just generate that. And now that one's done, we go back here, mesh, we can insert the sizing ones now. Now we need the edge tool, so I can click on the left edge here. And the right edge here, and we can apply those two. Now here we do need to change some settings for these two sizing ones we're going to do. This type needs to be number of divisions, and we're going to make the first one 100 divisions. We do not want to capture the curvature, and the behavior is hard. And then we can generate that mesh. I'm going to show you what they look like as we go, because it's kind of cool. So it's just the first one. We just did right now. We did another one where it was just a bunch of rectangles, but I didn't really show that one. That's the very first one. But this one's nice. We're going to do another one. And this one will just be the top and the bottom. And the way you click multiple lines, you hold control while you click, so you can get the lines to be selected. And then we're doing the same thing, but the number of divisions will change. We're going to make this one 300. No, and hard. Same thing. All that's the same. We can generate that now. And the numbers I'm using because of trial and error, from just having to try over and over to get like it to look just like how it should look. And finally I found a pretty good setup for it. So the face mesh here, we just click this. Everything here is already good for this face meshing. We can just generate it and let it do its thing. Now that we have that, we can look at it and it looks all black. Boom, we zoom in. You can see it's just really fine meshing of just a lot. And those meshings are good because it makes all those cells. That's really how this program works, and I think it's kind of cool. I'm not gonna lie. But now we can go back to Edge and click on each side now, and once we click on one, press N. Here, you can just change the name of things. Just give them a name. Do that for every single side. The top wall, the bottom wall, and this one you want to call, this one you want to call the inlet. That's where our flow will be going, the beginning of it. And the other side we will call the outlet. Perfect. All our name sections. This section is complete. Now we get to the real important part of this whole thing. Update this, open up setup. And once you get to the Fluent launcher, double precision, check that, and you can start it. There we go. It's loading in now. Perfect. There we go. Alright, so we start off, we click here, plus sign on models. We're going to go to viscous, and we're going to change this to laminar. That's what we're working with. Press OK. Now we don't have to really open that ever again, we can just leave that closed. Open up materials, fluids, air. Now here, we change the density, change mine to 1, make it real simple for me. And the viscosity will keep as this. We can change, create, and then we can close that window. I won't be taking this away because we will be changing it for the other cases. I'm just going to keep it open. But now for the boundary conditions, here we double click that. It takes us to this little menu, inlet. Velocity inlet should be the type. If it's selected or anything else, just change it to this. You want to edit that, and you want to give it a velocity. I'm doing 8 meters per second. I'm going to apply, close, and then all these walls should be stationary. Should automatically be stationary too. I'll just check to show that they are. And then we'll check the outlet. The outlet should be on the pressure, not the velocity. There it is. Yeah, pressure outlet. So it should just be 0 on both of those. Now we can start running this. Now that we've set up our inputs, we can start running this. Go to run calculation, double click that, and we can select the number of iterations we want to run. We're doing 200, and we can right click and then initialize and calculate. Let me just wait for this to do its thing. Sometimes it takes a second. Usually it does it for the second case. It takes a while. And it goes really fast for the first and third sometimes, but it takes a minute, a second. Now that it's done, next thing we do, we go results right up here. We go to vectors, we click new. Everything should be good, save and display. We can close this. We can zoom in, and now we can see our velocity contours and velocity vectors. And this pattern that it's making is going to be the end chart of what we're looking for. This is essentially just what we're looking for, but just here. But we're going to get it done in the chart so it looks nice too. But so far it's just going to be this. And it'll always kind of be the same thing as the chart right here. This is kind of like a good checkpoint. Like it's a good like check mark. You can check yourself just by checking the velocity stuff here. But now we're done here. We can get out, go to the results page, and we can open that up. And once this opens up, I'm going to close geometry and mesh because we're not going to need that anymore. Once those two are done, they're not really useful anymore because you don't really need to edit those anymore because it's not where any of your inputs are if your inputs aren't fluid. And then this just kind of showcases those. So here, we are going to set up a contour. We're going to have a lot of contours. We're going to have 100 on symmetry 1, and the variable will be velocity u. Everything else should be good, and we can apply it. Now, that's what it should look like. We're going to zoom in on that so we can just see it nicely. And we're going to change this legend so it doesn't look so in the way. Make it horizontal. Title mode. And fixed. And yeah, 3 decimals is chill. Apply. It looks a lot better. Now, we are going to zoom back out because this next portion, we're going to make sure you want to see it so you can actually see what's happening. I'm going to take off the contour so it looks just like this. And now we're going to add lines. These are the lines that are going to be used in the chart. So the first one is the midline. And it's halfway. Now we made our full distance 150, so that's 75. And so the reason I put 0.075 is because we did it in millimeters, but this takes it in meters. So you have to, account for that conversion and divide by 1,000 for each of the values you put in into this one specifically. And we'll give it a nice sample size of 100 samples. And we can apply it, and then we'll get a little yellow marker in the middle right there. That's just the midline. We can make a next one, and we'll call it the end line. And now, we don't want the end line to be on the end exactly. We want it to be just before the end. So we're going to make this 1499 because it's like really close to the end. 1499. And then that is just the same. It's just, the 2 points. Give it the height. Sample 100. And we can apply that. And now we have a little yellow smear right there. It's a little hard to see, but there is one. There is one there. You can turn the contour back on. It doesn't matter anymore. And now, chart. Here, change the title. Just going to call it profiles. Perfect. And we can go to the data series, and we can assign the data series to the lines that we had made. First one will be the midline. Call it midline here. We can add a new one, and we'll assign that one to endline and call it endline. Then we can go to the x-axis, make the variable for that velocity u. Go to the y-axis, make the variable all the way on the bottom. It's the y, and everything else should be good. We can apply it now, and we should get our graph. Perfect. That's the first case graph. Looks just like the case it should be. In the very middle, highest velocity, and there's no movement of any walls. It's just flow, just initial velocity of the fluid. Now we can go back to our fluent, and we can go to those ones I left open here, because now we're going to go to the second case. Here, we go back to air, and you want to change the viscosity and make it this one. Close that now. Go back to boundary conditions. Now the inlet no longer has velocity, so we need to make it a pressure inlet. And just keep those pressures at 0, and then apply those. We can close it. Now the outlet should be just fine. Now the top wall is the one that needs to be moving now. We're going to move it at 8, same speed that the was going at before. Just keep it 8. Apply that. Close. Should have a save, right? Yeah, we're all good. Now we go back to run calculation, still at 200, and we can initialize and calculate. This is the one that takes a minute usually, but hopefully it doesn't take too long. It does take a second though. But it will just end up giving us the chart, and it'll display it right here. It's pretty cool, honestly, how it all works, but just kind of sucks how long these things take to run. and do all these iterations, but I mean, I am the one that picks the number of iterations, so I guess that's my fault, huh? What are you gonna do? Should be close to finished. It usually doesn't get all the way to 200. It stops like before somewhere, like at 60 something, around there. And then it just ends it. Oh, no way. 70. Epic. Okay, speeding up. 90. Finally, it's done. And I can't believe I said it'd be 60. Got to 100 iterations, that's insane. Well, this is it. That is what our chart will look like. Now we're done here. Go to the next one. It'll instantly just ask it to refresh because it realizes that something changed. And it's just going to draw our graph for us right now, our little chart. Just to show that it is linear. Perfect little linear line. There you go. Now for the last case is the mixed one. So this one you're just combining both elements. So we're going to go through, we're going to change everything back to what it was. 1, -5. Change that. Close. We can go back to the boundary conditions. The inlet can go back to being a velocity inlet. And we can make it 8. Apply. Close that. Everything else, this should be good. This should be good. They don't change. The top wall does go, yeah, it's still moving at 8. That's good. And then we go to the calculation, 200 iterations, and now we can additionalize and calculate that. I think this is the one that stops around 60. If I'm wrong twice, that'll be a little embarrassing, but hopefully it'll stop at 60. It's going really fast too. It's a good thing. 55, I'm still off. That's crazy. Well, this is the chart that we're going to have. It's just going to be a problem that's kind of just skewed vertically a little bit. Has a little bit of skew to it, a little wider, I guess you could say, but still from like the origin. So let's go check it out. Refresh this. It'll do its thing. And there we go. We have our chart. So those are all 3 cases. And it looks just like them in the depictions that we see. So that means it does work. Pretty solid. We can now call this video flow. Just for the video. Well, I hope that was informational and somebody got something out of it. Have a great day, guys.